So this class, yeah, with the COVID and stuff, we were fortunate enough to be online, but yeah, we still had to have some hiccups along the way with prototyping. But um, I'm just going to give a quick overview of just where we're at this semester and I started to frame this class. Um, so the big part was how do you start to utilize computation and prototyping in a workflow. So using my own personal experience in the professional realm, we started looking at modeling the problem, looking at feasibility studies, and setting up computation scripts to help solve a problem. In this case, it's a feasibility study on a site, and you're actually, and I've asked the students to start to script the zoning of the site. The next assignment is when we start to understand the massing of it, the potential, the maximum yield that we can get from this, and start to generate floor plans from this. And I've asked them, since this is all scripted, we could generate hundreds of floor plans very quickly. So they were able to generate about 150 floor plans for this assignment, and they're just very diagrammatic. But then we can start to, once we have this massing, we can start to rapid prototype it and start to 3D print it and understand its form. And again, starting to understand the potential that this has, but also looking at and capitalizing on key opportunities that this massing has. So we were asked to run through an optimization script using Galapagos, to start to rationalize this twisting of the tower. And so the twist of the tower would go off picking the best views that the students would select. And again, updating all the floor plans. And then once we had a mass that was rationalized, we need to understand the benefits or negatives that it has with solar. So performing a solar analysis on it and learning from it, and then again re-prototyping it and making sure we get that loop, that feedback loop, using the computer. And then once we started to rationalize that form, we were then transferred this into Revit and used the power of Revit and its documentation and the interoperability between computation and Revit, and to begin to look into it and again document our design. And the final step, the comprehensive one, is now that we've rationalized this form and we've performed analysis, how can we start to develop a skin for this object? And how can this skin be reactive to our analysis that we've performed? So that's where I'm hoping, that's what today's class is, to start to explore skin designs. I've asked them to come up with a design module. This design module will have to go through a series of operations that will behave through key variables, which will then be cladded along the tower. So hope so I hope we're gonna have some great discussions. But John, why don't you start us off?
Sure. Let's see.
Also, just so the way we set this up is we'll have all the students present. We have about 3 minutes of presentations. Then I planned out that we'd have maybe 7 minutes or 7 to 10 minutes of feedback. The due date of this assignment is actually May 12th. So I wanted to give the students some time to react to the feedback and discussions on this from this review.
I'm just having a quick issue trying to share the screen.
So part of this assignment was to come up with that design module, to come up with elevations of the design, and to start to use the 3D printer to get that feedback loop of design. So 3D printing their design modules, and start to fabricate some of the connections, how each of the modules will actually work together.
Question,
And,
John. Oh,
yeah.
Sorry. How much should the students be sort of migrating away from their narrative? I mean, the narrative obviously got things started, but at some point, you know, is it truly relevant anymore, or is it what kind of balance of the narrative?
The narrative, yeah, that's a great point. So at this point, I think the narrative is the way they should always be referencing that narrative. That narrative never goes away. It's just the impact of it may be less and less of it. So when you're getting into the nitty-gritty details of it, or some of the concepts of the connections, you may reference there is a loose connection to this, to the narrative, but it still is always that present. How's it going, John?
I may need to come back after somebody else. I'm still
Okay.
working on some issues, so I'm sorry about that.
No, it's okay. Hey, Megan, do you want to jump in?
Sure. Okay. Did my screen pop up?
Yep.
So just a heads up, this document is very much a working document. So I just lumped everything in the PDF form. And you said 3 minutes, so I'll just kind of breeze through this. Most of y'all have seen this already. I live in the South on the coast, and certain weather elements down here can be difficult. So I look to nature for my inspiration, and chose the palm tree, which has a bunch of really interesting architectural elements to it. Some rough drawings, some diagrams, some rough sketches I did. And to get down to the 5 modules, this was my first module, and I was looking mostly at the bark of the palm tree, just kind of plain. Here's a 3D print of that. Most of y'all have seen this one. This was my second module, and I was trying to be pretty crafty, kind of meshing 2 pieces together. Here's 3D prints of those. I really liked this, but I just kept running at Ask John. I kept running into like script issues. I could not figure out how to properly script it on the side of the building how I wanted to. So I moved on from there and tried to take the natural elements, which I actually was running more into problems. You can kind of see here, I was trying to get it smooth, kind of like as you see out in nature. Tried to bring that into this panel, and the big jump from here to here, as far as the script goes, is I put everything in one panel, and it got infinitely easier for me. But I did lose a lot of what I wanted to communicate, but that's okay. I think I got it back in this final, and you can see here, this panel here to here 3D printed. I kept running into a lot of things with those smooth surfaces I was trying to get. So I had to abandon those because I don't think it would be very easily constructible. And my final module is this variation, variation 5. And it communicates everything I wanted to exemplify from the palm tree, from the narrative, and taking the process in mind. And well, I'll just keep going and show y'all. Here's a 3D print of it. I don't know if I want to go in this order. I'm going to jump down real quick. So here is the module in the in Rhino. I kept running into difficulties this afternoon trying to get it to render properly, which John will have more questions for you. down the road. But here it is on the building. Here's a couple other different views. And as far as materiality and connectivity, fibers kept coming up in our previous classes, and I got really excited about that and looked to Miami, Florida for inspiration because it has similar climate issues, aka hurricanes, moisture, etc. And got really excited about the 1000 Museum, and it uses glass fiber reinforced concrete, which I've never run across, but sounds like it's pretty popular, so y'all probably have heard of it. And it has the same fibrous tissue as palms and structural. It seemed like a good fit for the skin. So I'm gonna go off of that, and I think I'm gonna use C-clips, some variation of C-clips to get the panels onto the side of the building. Still need to work on that connection drawing for you. And let's see what else we got here. My grasshopper scripts, which you can't really see. This is trial and error, trying to play around. So that's the short of the long of it. Do you want me to share my Rhino screen or?
No, I think you're, I think we got it. I think one thing that kind of stands out was when you're saying where you had these ideas that you abandoned just because you weren't sure how to use the program. And
yeah.
So there's always a lot of different ways how you can do it, but the key thing that we really try not to do is, this is still a tool, and even though the idea, there are so many other ways that we can express the idea now, like the scripting and even Rhino are at the end of the day, they're tools to help us. But there are still a lot of ways that we can sketch out the idea and then start to map out and understand the logic behind that. And I think there's a lot of the sessions that we went through and some of the tutorials that I've shown, I think we can work it through, but I think work through all that stuff. But I think at the end of the day, it's like start with a sketch, and work your way through it. Like understand the logic of each, like what's the panel? Does the panel move? Does it offset in a certain direction? Well, why does it do that? And then we can start to articulate the logic of it. And then, we can go write the script for it. And a lot of times, like sometimes it may not even make sense to script the actual module, but we could always 3D model it in Rhino and later on start to apply it on the facade through Grasshopper. So I hope that doesn't hold you back as like that this is like, I don't know the tool, so I can't do this. There's always ways that we can do it. And there's all those different modules. I hope you just understand that there's pros and cons to each one of those designs through your concept and through your ideas, and not just abandon them because, oh, I just can't do it.
I think the message I wanted to convey, I'm able to convey. I don't think my little brain could figure out Grasshopper in the 2 or 3 months or whatever it's been. It's an awesome program and I love it, but I promise, I've been asking you questions for what, I don't know, I'm on every health session. So I gave it my hardest try, I swear to you.
Can we see your Revit model, Megan? I'd like to see how it actually relates to the floor levels and then ask about the variables that it can change with respect to.
What do you mean the other model?
The Rhino model. I wanted to see the floors and the modules superimposed so I can see, does it span 2 floors?
Oh, I see what you're saying. Hold on, let me move this out of the
Or I'm sorry, I meant the Grasshopper model, something with it live so I can see what's inside.
Oh, and the Grasshopper?
Well, either one, so long as I can see floors.
So you can see floors.
Yes. Does it span 2 floors or is it a 1-floor module?
it's a skin, so it's not really specific to floors.
Ah, so it's not actually parametric by floor then, per se?
No.
Ah, okay. Did you want it to be? I mean, your original kind of palm frond design seemed to have, something that related
Yeah.
or could be based on floors.
It did, and then I ran into,
Issues.
I didn't want it to be specific to the floors because then I couldn't get the height I was looking for, if that makes sense. So I wanted the actual shape to be bigger.
So can you show us then which variables are actually still at play in the design that you have, or in the module that you have? How responsive is it to whatever variables?
How responsive is it to
what can you vary
to the
about it?
original that I had?
No, based on what you have right now.
The heights between the modules, or
Yeah.
I see what you're saying.
Is there anything that
So-
moves with respect to a variable?
So the heights comes from here, comes from, it's not showing right now, but it comes from here. I play with it here.
Okay.
On these markers.
Can you go to it again so we can see? That's U and V. Are there any other dimensions like, depth in and out of the surface?
Yeah, there's sorry, my
That's what I'm saying.
computer-
So if you had to list the number of parameters that you can flex, we'd have U and V and what else?
There's at least 3.
Okay.
Okay.
I'm losing my computers. My computer's brain hurts as well today. Where did my grasshopper go? There it is. Okay. So then within that, I also have these factors. So it's able to go coming protruding outside of the building. I have a factor of 4. And then as far as the module being to the building, I have it 2 factors out right now because of how it was laying. Part of it was hiding, so it needed to come out a little bit.
so you could potentially sort of, longitudinally have a depth variable with also the way it's divided in X and Y.
Correct.
Okay.
Yeah.
What I was curious about is how do you position this 3D printing with this exercise? Like, was it to sort of test out the geometry, or I mean, what we're exploring in my class is like using 3D printed forms as like formwork, which I think would be. So I'm just trying to position where 3D printing fits in. Is it to sort of do like rapid prototyping of like half scale modules or something of that sort? Or maybe
Sure.
this question should actually be diverted to John.
Maybe a little bit of both. For myself, I used it as prototyping to kind of see how it would react in a 3D form and a physical form. But I guess John can kind of answer more of what he wanted specifically out of the assignment. I don't know. I don't think I actually did it how he wanted it to the assignment. I think you were looking for 5 similar modules.
Yeah, so that part of it was, to actually understand, like, when you make something, like, of how the fabrication of it, the form of it, just the process of the fabrication, you start to understand, like, efficiencies of it. Like, hey, well, is it going to print faster if I start cutting out pieces, like, start hollowing out this piece here, and does that influence the design? Or how does that even start to, thinking about even the fabrication process of it, of the modules. The other part was actually how the modules fit together and actually start to interact with each other on a tectonic level, understanding the details of it. A lot of times with these panels, there are so many. The panel itself isn't the most important thing, it's the connection. So, and that's not true in all scenarios, but there's that level of fabrication that it starts to uncover and we start to discover new opportunities. And so that's where 3D printing, writing a script, or even just 3D modeling, printing it, and then writing the script, that 3D printing process was supposed to help inform them to get that continual feedback, that loop of making something and then learning from it.
Right. and to sort of see how what you're physically printing actually informs the design process to sort of go back and start negotiating almost.
Absolutely, yeah.
Previously, in what you had done, Megan, do you have images of like the previous steps from this? The optimization or the other to sort of show Mystery where you've been coming, where all this came from, kind of earlier steps in the design.
I do as far as
On the tower, yeah. Before the
oh, the whole tower, like
your original model layout, which was really lovely. Your original layout.
Not.
You have it from before. You have it from before, right? There, right there. So
Yeah.
zoom in on this. This is why actually I was assuming there was a floor relationship because it has a background
Right.
grid.
There was here, yeah.
Okay, all right. So this at this point you were still thinking in terms of floors, right?
Correct.
Okay.
Yeah.
Can you just actually describe what it was that became difficult? I have some ideas about what became difficult, but what if you had to describe what was difficult about this? How would you phrase it?
I wanted to learn Grasshopper, so I mean, I guess I could have like just through Rhino just pieced it together, like physically drawn it out. But I really didn't want to do that. I wanted to like learn the program, so I really tried my hardest to like figure out how to get it in Grasshopper. But I guess the extrusions here, like I had to extrude, so I had trouble finding this point here. And then within the script, there were so many extrusions, like within one chunk, I had like 5 or 6, and I just couldn't figure out how to get it to run correctly.
What I'd suggest actually is that, and this is for everyone, this is a concept I think regarding panelization. You had interactivity of design points between panels. And so I think you ended up with like irrational numbers in a certain sense, or something that was indeterminate where you really couldn't sort of actually get a point. Many people have limited or bounded their pattern to the outline of the actual panel. Whereas yours, in a sense, many of the points that determine something in this panel are over in the next panel over here.
Right.
And so I think that spread of the design across the panels is what is really beautiful about this. But I think it also makes it a really hard thing to script.
Yeah, I can figure it out.
Yet, you will. This is worth the challenge. Actually,
Yeah.
I mean, even with the way the geometry is sort of coming together, I think there's like room for scratching your head about how do these actually come together if you're talking about GFRC or sprayed concrete with fibers, right? Because then you also have a really good window to sort of explore like metal details, or I mean that's more on the fabrication aspect of it. It's an interesting material choice too. What sort of led you to it, or maybe pick concrete or anything else?
Because the fiber kept coming up in crits, and palm trees are held together essentially by these fibers. That is their connection tissue. So I wanted to parallel that, and kind of just stumbled upon it when looking at similar climates and architecture in those climates. And it just seemed like a great fit and something new I've not learned about, so I wanted to learn about it. And as far as moisture content here, that's huge. Concrete does well. It just seemed like a good fit. It's a little lighter, so it could do, there's lots of attributes about it that led me to land on it.
let me suggest also too how you might have envisioned or made the connection between your narrative and the shapes. So show us the actual palm tree again, and then show us your shapes that you originally printed. All right, so take a look. Hang on before you go anywhere. All right. So you could choose to make this in a deep sort of half circle thickness, or you could think of it as just a plane. And so what I'm suggesting is part of the problem may be having given a depth like this, okay, versus simply seeing it as overlapping chunks. So if you could imagine this as just simply spears of metal, for instance, or whatever it is you wanted to do, that maybe kind of overlapped, but weren't thick. Think of them as simply metal plates that could have done this endlessly. So you could almost script these triangles separately and then let them spill over the side of your module onto adjacent modules because they're all slipping and sliding anyhow. My bet is,
essentially.
yeah, my bet is there's a way to simplify your pattern as a set of separate planar sheets that would allow you to achieve the pattern while still tying all of the parameters to the panel module itself. I'll bet that. I'll put actually money on that.
I know there's a way.
Yeah.
I don't doubt that it's possible.
Well, I know what I'm saying. I think
I've seen
actually the important point for the class is how you take your narrative forward. So yes, it's a palm tree, but maybe not. It's not really a palm tree. Maybe it's a start for a pattern. Okay.
Yes.
So so the lesson for future classes, I would say, is beware of your narrative because you may take it too literally. And I think that you could solve a lot of your problems by thinking of it in a different way while still keeping the complexity.
Okay.
Yes. That's a fantastic, like, this is still, it's a concept, and we're not trying to exactly mimic the palm tree, but we're trying to learn the characteristics that could help influence our design into it. So it's not, having it as a plane and not the actual shape. Is there a certain behavioral aspect that may be a benefit for the structure or for shading and or something, but it's not, we don't have to directly copy it. It's just we're learning from certain characteristics from it.
Go to your image that we were looking at a minute ago, Megan. The one of the complex panel.
This one?
Yeah. Okay, so imagine if, I'll just take a larger chunk of your panel here, okay? Imagine if all the parameters you needed were in there, then I'm going to change colors, okay? Imagine if your panel actually extended past it. And so your triangles are actually bleeding beyond the edge of your module, okay? And so let's just say it's this one right here, that one, and then this one right here. And then this one goes up and stops just after like that, okay? And then maybe that's actually maybe your repeating unit right there, and they all bleed over each other. Then you can begin to rationalize where you catch some of the stuff, and some of the interactivity goes away because it doesn't actually matter whether that point lines up. You don't even need that point anymore because it's actually made up of an overlapping piece of metal. So I guess, yeah, so it's actually simplifying the way that you imagine this as not a coplanar grid, but as a multi-layered set of triangles that have, that are free to interact. You never have to know what the interactions are because they're overlaid on each other. They're superimposed.
Okay.
Yeah.
That makes sense.
So I'll wager the solution is down that line somewhere.
Okay.
How much would you like me to bet?
All right.
Okay.
All right. Thanks, Megan.
Thank you.
Hey, John, are you you got your stuff up and ready?
Yeah, I can go.
Actually, John, Carl has stepped in. Could you want to do the briefest introduction? Carl, have you seen?
Hey, Carl.
You can keep going. It's okay.
Okay. All right. All right, John. You want to start?
Sure. Okay, can everyone see that?
Mm-hmm.
Okay. So I framed the twisting tower that we designed, shown here in the center, in my home state of Wisconsin, so in the city of Milwaukee. It reminded me of a few different buildings that I've seen, more recently built in Milwaukee. The Fiserv Forum here has some interesting curves, as well as the well-known Milwaukee Art Museum, shown in the upper left-hand corner. And so this form that we were working with, that I 3D printed here, reminded me a little bit of different aspects of both of those buildings. But Milwaukee is also historically a manufacturing city, and so I wanted to incorporate some part of the design that would give nod to its manufacturing roots. And so one of the other well-known buildings in Milwaukee is the Harley-Davidson Museum. And so I used that for some inspiration. Kind of zoom in here and noticed some of the forms that were used in that design as well. And then, so playing on that theme of manufacturing, I envisioned, it reminded me of something like a welder's helmet. And I can imagine, you know, in the Harley-Davidson plant, you know, welders welding frames of these motorcycles together. I've even had a little bit of experience with a welding class or two. And so I came to appreciate some of the new generation welding helmets that darken automatically. And so I used that in kind of this trapezoid shape to model a panel here, or a series of panels. And the ones that I ultimately selected are shown right here. And so what I envisioned is that this panel would modulate and would be dynamic based on its relation to the sun. And so what I did was came up with these dynamic solar facade panels. And you'll kind of see a call out here of how the panel responds to the position of the sun. And so what I used Grasshopper for was the Ladybug solar analysis. And so here's a few different elevations. And in the next few slides, you'll be able to see a little bit clearer how the panels respond to the sun. But in any case, the elevations really are dependent on what day and what time throughout the year. So again, those are kind of zoom in here a little bit to show you some of the difference of the panel here versus towards the top of the tower. As the panels get closer to, or as the panels get closer to the sun, they restrict the amount of solar gain into the building. So these next series of slides, I've modeled 5 different positions of the sun. You can, I don't know if you can see the sun here. This is about 6 or 7 a.m. in the morning. Here's a top view of that same thing coming in the east. And in this case, there's a call out of a closer view of those panels. And then as the sun rises throughout the day in 3-hour increments, the panels respond again based on how close they are to the sun. And then I played around with some different renderings, trying to bring the Rhino model into Photoshop. And so this was a site in Milwaukee that I just picked near Lake Michigan. There's my Grasshopper script. And I'm still working on the connectivity aspect, and I'm having some trouble with my 3D printer, and so I think I'll end up doing the simulation aspect, something related to what I showed here in this series of slides.
So John, a few things that come to mind when looking at this was you displayed like the domain and of the ranges of the openings, and there are some that are completely shut. And so are there's areas of the building that you just can't see out, that it's shut?
Sure. I envisioned something similar to almost there's different types of glass films that where somebody can see out, but that restricts sunlight in. But
You get, I mean, that is something to think about. It's like when, if
Sure.
it's completely shut, is there, other than the solar exposure, is there another reason why it's completely shut, or is there a limit to how big it gets?
Sure, I could adjust that in my Grasshopper script. There's a that's done with a scale feature, and so see if I can find it here. But I think I could adjust the limits on the scale so that it may not entirely shut. I was still working on that.
Yep.
Perhaps is there a way to think of it, John, as not so much opening and shutting, but as changing proportions? So your rendering actually makes it look like a glass skyscraper, which would lend credence to your thought of a different kind of glass usage. So this is really a glass density or opacity, or not opacity, tint, whatever, proportioning mechanism as opposed to an opening and shutting.
Sure, okay.
How about the depth? So looking at what appears to be glass here, it's one thing to mix up the various opacities of glass. How do you see the depth aspect of each panel playing out in this particular sort of rendering you've got here?
Sure. In this particular rendering, the depth is consistent for all the panels. I think it's currently at 1 foot. That is something I could adjust in the Grasshopper script, though.
Do you still have the appearance of a chamfered side? So it was essentially a 45-degree angle on each side that opened and closed like this. Does it have a panel thickness in that regard that's just kind of moving like this? Are they truncated pyramids? Put it that way.
Yeah, they are. The obviously at the extremes, it's less visible as opposed to the modules in the middle like this. I believe it would be more visible.
A good rendering to have in the end might be something that actually shows the dimension of the panel when it draws up, tight as opposed to being more flattened out like that. That would just to show the variation.
Okay.
Yes.
Sure.
Yeah. Also, how big are these panels? Are these like a floor to floor, or how many per floor?
Sure. Currently, I think one panel would be about 20 feet. So it's and I can adjust that in the script, but currently it would be almost 2 floors.
In another aspect of how these function, and you're talking about the dynamic nature of it, is like, how do they just conceptually, how do they even move? If it's
I haven't it's a good, I'm still working through that. I haven't quite solved the engineering part of it.
Because it seems like you'll have that fixed glass, and then it seems like there's this oculus on top of it that adjusts.
Sure. Yeah, I envisioned it as a secondary skin.
Okay.
But maybe I would argue that the last thing you should do is take this on as an engineering project.
Yeah.
Or even a facade
Sure.
project. The facade is it's an alibi. It's an excuse to, it's a random thing where we have a whole bunch of parts and they all stack up and they all make a surface, and that's as much as we need to know about a facade. I'm actually more curious, and I didn't see the setup, and I guess that won't stop me from talking about these things in terms of what the project is. But what if the design was the programming methodology? What would be a more robust approach that way, right? And I think so. What you have is a part that can exist between open and closed. But what if rather than on a single line, right, where you have a spectrum, what if that were a kind of XYZ, which was between open and closed and thick and thin, right? What would happen when, rather than just mapping this part that can be open or closed or anywhere in between across the surface, Like the glass could be totally open, but it had a shading element because it had thickness. And how would you move between these two parameters as opposed to just one? You know, it's like the difference between linear, double axis as a methodology, or even 3 axes, right? It could be open or closed, thick or thin, and something else. And your parameter or your part, your unit could exist anywhere within that 3-dimensional matrix, and you could start to map those. Like, then how do you map those across the surface? And I'd say the same thing. It's like only sun is mapped on here. What if it were sun and like if it were housing, it's like values of the unit. Or if it's an office building, it's like the corner office is more valuable than the other unit. Like, how do you start to deal with multiple? I think it's very rare, although I'm looking out across the city of Detroit right now, and they're all probably really simple facades in terms of the way that they deal things. But how do we deal with multiple things where you have to kind of compromise those things, right? And so it's less of a critique of like, you guys are learning how to do this, you're doing it, and rather than trying to come up with the best facade, like, how would you present the project not as a facade, but as your Grasshopper methodology? And like, where are the limits with that? And what are the constraints of your Grasshopper methodology? And when are you like, is there a certain sense of like you guys trying to one up one another? Like, I got a loop. Oh, well, I got this kind of loop. Oh, but I use 3 variables. Screw you. I got 4 variables. Like, where's the one-upsmanship within your Grasshopperness, right? As opposed to like, I mean, this is like the renderings of the facade are just ridiculous, right? It's like, it looks like it's on a little park. There's a totally like, the rendering is like, it's not about the facade. It's about an application to be able to deploy this smart part that you've come up with. And how smart does that part become? And how do you start to describe that meta methodology to us? Not in the terms of the facade, but in the terms of your programming prowess. Show us your, and I say this, and I actually like detest the presentation of Grasshopper scripts as a thing, but show us your Grasshopper and show us where like the coolest part of your Grasshopper script is. I know it's a weird question. I know you weren't prepared.
Sure. I was working for a long time, and I was actually pleased just to be able to work out the dynamic between the panel and the sun position, which is kind of incorporating the sun path up here. And yeah, I guess I'm not exactly sure how to answer that just yet with the script I have, but
what are all those sliders doing? You don't have to individually control all of those things, do you?
There's no doubt probably some redundancy there that I could clean up as I learn the program a little bit better.
Like, zoom in a little bit on the right-hand side there.
Carl, I want to hear why you detest the presentation of Grasshopper scripts. Why are you biased against them?
Because it lacks convention for us to be able to have a discursive, to be able to discuss them.
Well, that's easily fixable. So is there a reason to detest it? Or we should just get more rigorous about it.
Maybe. I mean, like, it's the same thing. It's like the rise of the cut sheet as a drawing that was presented a long time, like in the 2000s, right, or in the early 2000s. It's just like, it's just a byproduct of a process. It's not something like, we can't talk about what you did in a Grasshopper script and see it. It's a demonstration of like complexity, which one cannot get into without giving me 3 hours to work through it. Right. And so you throw it up on there. It's like, that's a beautiful bowl of spaghetti. Nicely done. Like, I can't talk about the Grasshopper script because you're not giving me the information. But if you zoom back in on it for a second, like are each of those sliders things that you have to independently manipulate? Like zoom in on the top right. Each of those kind of clumps has a slider that says index, right? One is set to 2, one is set to 1, one is set to 0. Are you manually controlling all of those?
Those were to try to get points within the module to control. So
yes or no?
Yes, I can control them.
But once you set them, then they're set and you don't go back and change them, or you do?
In this model, I have not gone back and changed them.
I mean, that, and I point to that just as an example is like, you know, I have one dial and I can change the dial, right? I can turn it up and I can turn it down, but it might like do radically different things, right? Or is there random numbers embedded within there so it produces something that I'm not aware of? Or do I always know that I can dial it anywhere between here and there, right? Or it's like, right, that ability, like you've almost produced, and granted you said you haven't gone back and changed them, but it's like there are so many parameters in there that I would have to go back and change. Like, do I start to think about it? Like, I guess what I'm trying to discuss is maybe a kind of attitude for you about like, what's your relationship to the Grasshopper script, right? Are you just like, you just check in on it every now and then? Or are you like micromanaging it, right? And like, wait a minute, like, no, that one needs to dial up, this one needs to dial down, this one needs to happen, right? And so there's a design intent related to those in terms of your maybe willfulness or your intent as a designer, right? Do you allow the Grasshopper script to show you something that you hadn't considered before? Or are you so dogmatic about this thing that like, it's gonna return the result because you know exactly what this is, right? And for me, that's a kind of design aspect, right? Do you allow it to show you things, or you're always gonna show it things, right? And so maybe throughout the course of tonight, we can talk about some of those things, or that might be something that's at stake as a computational designer. And they may exist at different points in a process. And an early stage in a process, I want Grasshopper to return something to me and surprise me. Late in the process, when we're getting ready to go out to bid or we're sending the drawings to the fabricator, we absolutely don't want that to happen. And so maybe dynamically over the course of the design process, there's a way that we start to kind of clamp this down and rein it in and allow something else to happen, right? But in that analogy, we understand the Grasshopper script is something that's dynamic and wild, and we tame it over the course of the process, right? And again, for me, there's a kind of design intent that you bring, like you're designing not only the facade, you're designing the methodology that we see on the screen right now. And that's something that's excited me. I know that you didn't approach it that way, but I think that's like an opportunity that we have when we talk about these types of things.
Okay, thanks.
And also I'll say, you know, for everybody, as I talk about things this way tonight, I know like final reviews are not they're not, or at least the way that I would approach a final review is not a kind of validity check about what you've done. Like you have that moment between you and John and you and your instructor and you and whoever you're working with on a day-to-day basis. I think the opportunity of final review is like, holy crap, like what could this stuff be in the future? 5 years from now, when I come back and I think about this course, like what might the opportunities be, right? So I'm like trying to open the discussion and be a little more wild tonight. I've also been on so many reviews today, like I just start to have some fun too. So like, I apologize.
So would you say, Carl, that the script can have agency of its own? And this is for you, Mystery, and the robot. Can you script something where it produces something you didn't expect? I don't know about the robot. Your mic's on your mic.
Well, I think there's a really good sweet spot where the robot tells you something you wouldn't imagine to like come out, almost like a feedback system, because then it sort of gives you an end product, but then it also informs what the first step should be in a certain way, which almost creates a conversation instead of you just saying, okay, this is what I want and this is what is almost like pooped out of the script, but instead to sort of start debating with the script itself while you're making it, just because it gives you a whole different product with just a small little change in the slider. Also, with the way fabrication has a few limitations, which is why I was actually curious about how you're using 3D printing as a way to sort of see how these pieces come together, or think of it as a process altogether, to sort of think back and say, oh, 3D printing is great for a certain kind of geometries, but maybe it wouldn't be too good for certain geometries. So then again, it's starting to question the process itself as an agency.
Right? And it might be back to those issues of like where it is in the workflow too. I think like in the way that you're talking about the robot, there's a kind of, maybe that is a kind of validity check.
Yeah.
It's like, can it perform this way? Yes. Like you don't want the robot doing crazy things outside of its boundaries that could be dangerous. And that's also like where it depends in the process, or what those limits you might impose.
Yeah. Also, with the way you're talking about these glass panels being about 20 feet, but that also means it's, or maybe it's much larger than what a typical standardized element, which is a 4x8 sheet. So how do you then sort of start negotiating with the size constraints of how typical materials behave in most cases? So would that then mean you go back to your geometry and sort of start thinking about connections more than in its entirety? Or how do then 4 pieces come together to form one piece, which in your case is a 20 by 20 sheet, which is also a really good window to sort of start questioning it.
That's the beauty of the computation, and how it complements the fabrication process so well. Is you can, you have that feedback loop of, okay, maybe a 4x sheet, we've laid this facade out by a 4x8 sheet, but 4x8 sheet isn't the most optimal way, and I have 1,000 unique shapes. Well, I can actually just tweak one variable and it will update, and now I can start cutting a 30-inch wide sheet. And it's so easy to quickly tweak these variables and get a faster optimized fabrication process.
The example that I love is the museum that Foster did in London. The one that's the kind of donut over the courtyard. It's the Royal, I forget the exact name of it, right? There's a round piece in the middle, and it kind of is a triangular glass panel.
Yes.
The glass sizes, the limitation of the glass sizes weren't determined until fabrication, because it was the glass is fritted, which is a ceramic coating, and it was the size of the fritting ovens that determined how big the glass could be, right? There's no way you can know that until after it's bid. And if you do that in a traditional process, you have to redesign the entire project from the beginning if you get to that point and you realize that your glass sizes were too big.
That's awesome.
Right? Whereas this could just be a slider. Oh, it's not 20 by 20, it's 4x8. Done. Whole thing recalculates and it's done. But that's like where that occurs in the workflow, right? That's a fabrication related parameter compared to maybe a form finding parameter.
That's great. Well, thanks, John. This was hey, Nate, you want to go next?
I can do that.
What's that?
Yeah, I can do that.
Okay, cool.
So when I had started looking at my facade concept, one thing that kind of interested me was potentially using the wind that would be acting upon these taller structures, some type of benefit to the building itself. Can came across a vertical turbine that really looked interesting to me. And so I thought about how I could use a panel to direct that wind in between the exterior facade skin and the building itself to then turn a turbine and maybe offset some energy costs for the building. So I did some initial mock-ups of a shape and then just kind of mirrored it over. Kind of my thought with this is that panel A would have an opening that would let the air in, rotate the turbine. Panel B would be a percentage of the panel A opening to let the air back out, so that the panel Bs would not block the full airflow to the next series of panel A. That was kind of the starting point for my design. Here's kind of working through my script and keeping that initial panel in mind. I wanted to try to get a wind tunnel put together, but I had some increased difficulties with that and kind of had to put that to a back burner just on time constraints. But I was able to work with some wind data to help me understand where the wind was impacting the building, and then using some different parameters to hold the building up. So here's kind of it's not as big as I would hope, but the panels moving in and out on the building. And zoomed in one, where they would kind of open up, and then the panel B would open up to let the air out, and then the turbines in between. Here's kind of, my wind analysis kind of showed that this side of the building, which is here, does not experience as much wind, so it wouldn't be as financially responsible to put a bunch of turbines and paneling on that portion of the building, as it wouldn't give any return. But the other sides of the building do experience a good amount of wind. I did hold the panels up, like I said, just mainly because of the surrounding architecture around that would complicate wind flows. That's where I really wanted to see that wind tunnel data to know exactly how those surrounding buildings would impact that. Here's a 3D print that I did of 4 of the panels together. I tried to do, this isn't that large, and I tried to do a small turbine, and it failed quite a bit, just a little bit up, so I just kind of used what I had to demonstrate that spacing. I did print it larger, actually quite a bit larger, and then I started experimenting with what the connection points would look like, and then trying to figure out how that will work dynamically as a panel's moving. Potentially this is the start of like a collection point, and then at positions where there's rotation, it turns into like a pinned joint that would happen afterwards, but still haven't really worked that piece out. That's where I'm at on this at this point. It's not where I want to be, and every time I solve one problem, I feel like I just create about 3 more that need to be solved, and so I'm slowly working through that.
Nate, what would you describe as the problems you're creating? I think it's maybe useful to talk about Carl's definition of a form-finding variable versus a fabrication variable. So when you change one thing, do you bust a fabrication aspect, or does it bust the design? Or does it offer new opportunities?
Yeah, I think it's new opportunities and new discoveries of how the panel would need to be altered. So in using this panel A, panel B series, as soon as I get the next series of panel A to touch, it starts interacting with that previous set of panels. And so the movement between them starts compounding against each other, and would need to be broadened out so that there's a little bit more space between the panels so that they can move independently. And I really hadn't thought that through in the beginning. Another issue that I'm having is how to get the turbines to align properly so that they're not vertical if I've got a rotating and tapered tower. And so the angle in which the turbine has to be positioned is kind of a complex angle that I haven't been able to work out yet, so that the turbines aren't puncturing out through the skin vertically. Those are kind of the major things that I'm still struggling with right now. The other portion that is hard for me is that when I'm dealing with a rigid body like I have, the movement really needs to separate here, and that corner needs to kind of almost track on a radius rather than the way I have it right now, where it is almost like a fabric panel. So if these are, you know, glass translucent panels, and I can't have a triangle that has 2 secured points and expect a third point to move without it breaking. So those are kind of, you know, some practicality things that I need to work out.
That's some of the interesting things about getting that fabrication involved, and how that fabrication process and the scripting can help and start to talk and have that feedback. Is, yeah, once you scripted something and then you made a quick model of it, you're going to quickly find out that, oh wait, some of these things I can make this more efficiently, or maybe this variable just doesn't work, or this pivot point doesn't work where I've scripted it at. You know, that's great that you were able to find that by making that model.
How much would you say, Mystery, in terms of your students, are they discovering things late in the game that then in some way stall or cause a problem with the process? I think that referring to what Nate said about discovering things late in the game, how are you seeing that in your class?
Well, fortunately, we got to play around with the robot quite a bit to sort of understand what it can and cannot do, which is what unlocked most doors. But also in a lot of ways, purely talking about fabrication, then like something like a CNC machine can only do like overcuts and not undercuts like 3D printing can offer. So then you're actually starting to pick one fabrication process over the other as well. So, I mean, it then doesn't just become like a form finding exercise, but also why you would pick a particular kind of fabrication process, which sort of aids or like links back to almost like the design in one way or another.
I think it's a tough question to ask, Nate, and this is for everyone. As you imagine what you've learned in this class, then applicable to subsequent design classes and subsequent workflows and processes, you might be able to say, hey, I have to do something first. I learned from doing it the way we did that I should really actually consider these things earlier in the process or something or other. Nate, would you have any comment on that? As you've thought about what you did, would you do anything different in terms of your exploration sequence?
You know, part of me has this point where I'm like, man, I should have just picked a really pretty design and just done that, and it would have been so much more simple. But I think that I wouldn't have gained the experience that I did by pushing myself and trying to figure out these problems. I think the rigid body dynamics, if I would have thought about that earlier on, I think I would have saved myself a lot of work, and just how those panels would actually move. And the funny thing is that I had that mock-up this entire time, and it's just sitting here this week with my wife, like, I just can't get this to work. And we set it down on a piece of paper and literally just kind of drew out how it would actually move, and was able to kind of plot the corner as it moved, and then better understand, you know, how that panel will actually move. And I think if I would have done that earlier on, I would have had a little bit more success on using that panel.
There was a benefit then in actually getting it out of Rhino or Grasshopper into something that you printed or actually could physically move as a physical element.
Oh, absolutely, 100%.
Yeah. I mean, we find frequently that many times students will want to keep something in the computer, and it's not until we get it out of the computer into a physical something that we can test that we uncover many of these problems.
Yeah. The faster you start to get something in your hands of like fabricate it, yeah, you learn so much more from that, and then scripting afterwards.
Yeah, I definitely felt like I drowned in my script for way too long, like just trying to develop it, hammer it, really get it to work out rather than just getting that first piece printed or that first, something in my hand.
I wonder too if there could be other criteria. I was thinking about, like, that was part of a workshop years ago that was with concrete and CNC milling and and I don't know if it would help you, John, with the class, but like, I feel like we gave the students a kind of like a matrix of things. There was like a surface quality, a concrete mix, and then there was also like a Gerhard Richter painting as a wild card, right? And I just like, it's like, okay, the first one was about like lighting, the second one is about wind. They're I don't know, I was starting to look at it as like, I wonder like, where's like the prickly parameter, right? And it's like, okay, they're all driven by a very linear kind of engineering criteria, like where the wind comes from here. And I say this to all of you guys too, because for a long time, I taught these types of things, and we defaulted to quantitative data that we could use. But I think there's also something like, how do you mix something in there? Is like the buildings that catch your eye or draw your attention or those types of things aren't just singular one-off responses to an engineering problem. There are other things that are going on. So it's like the reflections that start to shimmer off of this building, right? If you had rendered it with the surfaces, right, and as those panels pop out, they're going to cast shadows. And so there's these secondary and tertiary effects that start to be created by this. And I wonder just how you're like closing yourself off to those other byproducts by just allowing it to be this one thing. So it's like, and I know it's more difficult to have a qualitative slider. They don't really exist, and you'd have to kind of fake it to some extent, right? 10 does this, 1 does this, and let's like randomize something. Let's see what happens. Just trying to find those moments where, I don't know, something else might come out of these.
Oh, absolutely. It's, and what you said earlier, I think it was something that needs to get looked into next time, is that, yeah, design is a series of compromises. And the beauty is through all these compromises, when the wind, the views, all these different variables are battling out, it's what's the hierarchy of it that starts to articulate the beauty in those and create those special moments. But also, and there's also that human effect where, that maybe it's a post-processing moment, that the script sometimes, the output of it just doesn't make sense, and maybe it just needs that human touch to just go back and remove a few elements or tweak a few elements by hand.
Right.
But yeah, it's those compromises that add to this, and not just a singular, here's the wind, here's the sun, here's the views. It should be multiple things.
And I don't want to diminish the effort on that. Like, I know those are difficult things, and it is an accomplishment for you guys to have worked through those. But maybe I like how Eric challenged me earlier about complaining about how the Grasshopper scripts get shown. But I also think there's almost like a meta diagram that says like, and like the way that you just described it, John, is like, as a designer, which criteria do you allow to override the other criteria? And that's something that I feel like we always struggle with. And here we can play that out, because Nate, if you had done a diagram that's like wind comes in first, then this other criteria happens, and then another criteria happens, like we would see the result, and it's like, oh, maybe, and if those kind of cascade in a certain way, maybe wind doesn't come first, but this other thing comes first. What if I flip those and allow one to have a primary thing and the other a secondary thing? Does that result in something else? And I feel like whether or not you're using Grasshopper in the future, you'll always be confronted with those types of decisions. How do I do this? And being able to map them out. What I absolutely love, and why I'm a huge proponent for this type of class, is that Grasshopper or any type of scripting or any type of parametric modeling forces you to be explicit. We are always dealing with these types of decisions, but we're not so good as designers at making them explicit. And so this forces us to try and do that. And when we talk to a contractor, we absolutely have to be explicit to tell her to fabricate something a certain way. And so like the tool allows us to start to communicate in a certain way, right? Where you could be really clear. What I've done is I've taken wind, I brought that into the project. Then I was like, oh, prickliness might be another quality of the facade as it starts to crumple. How much crumple is too much crumple? Okay, what about from the outside, from the inside looking out? There's another quality. When are those within my range and when are they outside of my range? That's the way we design. And so what's nice about Grasshopper is it allows us to really have to share that, right? Where normally it's internalized, here we put it in the bowl of spaghetti that's up on the screen right now.
It's interesting. I just had a meeting last week with a client, and we were going through, and I wrote a Grasshopper script, and it had, we had 2,000 iterations, and we were like, well, all these different iterations, there's compromises to each one, and how do we show the client this is the best one for them? And it's like, well, we need to talk to the client because we don't know what our priorities are different from their priorities, and we need to have that discussion. And it was all about what's the relationship of these variables and why one should be better than the other. And at the end of the day, we didn't have one yet. It was like, let's go back and tweak it. But now we have a guideline of certain precedents that the retail should be the least precedent compared to the fitness center, or so stuff like that we were able to go back and start to tweak the script and establish those.
And so Bill Mitchell would always talk about Palladio as someone that was scripting a long time ago, right? What are those proportions? Why is a Doric column different than an Ionic column? Those are explicitly embedded notions about proportion, height, all of these things that we deal with, geometry.
Absolutely. Mm-hmm. Oh, great. Thanks, Nate.
That's my pleasure. Thank you, guys.
Hey, Ruby, you want to go next?
All right, so let me unmute and share my screen. Share.
And John, if you're keeping time, just say we should move on to the next one. I will not be offended. I don't know how many projects you have or how much I missed or anything. So
we're falling a little behind.
All right.
But no, there's such good discussions. I mean, part of that is this. I mean, we're learning through this at my work is just how do we even present and talk about this, even to clients, but also it's a lot easier to talk to an architect with this. But how do you start to establish priorities, and how do you start to explain this stuff in effective terms where people are able to get it? I mean, it's really easy to talk about this when people know this and have been doing this for years, but start to critique it and learn from it is a different one.
Do you all see my screen?
Yeah.
Okay. So what you're seeing should say Diamonds in the Sky Wellness Center?
Yeah.
Okay. I had a lot of tabs open. Okay. So this is my concept, and John already gave the background. I included some of that where we chose the site and developed our buildable area and did the Grasshopper calculations for it. and algorithmically modeled some changes for a client, and the floor plans for them and the scripting for them. So there was like 6 options that we did. I'll scroll on down. So my processor is mad at me today, but all right. So we got to a point where we did some rapid prototyping of a design option for review for a client, meshing and creating the 3D model to a particular scale. So I went from the mesh to a prototype to model, and then we did some studies in Galapagos concerning it in choosing a design or a layout based on that. And that is one of the ideas that evolved from the Galapagos. And I went on to do the solar study based on it and prototyped that particular version that evolved from that study. And then we went on to do the interoperability of BIM objects using Revit. But as the project progressed, we wanted to, my PowerPoint, it's loading.
It didn't even want to share the screen a few minutes ago. That took like 30 seconds to even share the screen.
All right. So we're now deciding on a module that would fit a design, you know, and thematically explain it. And so I had the idea of having my module be an external skin to the facade with a tubular connectivity between the module and the building and between modules. And this was the Diamondoid concept of a wellness jewel, where everyone is a jewel. And so that was just a preliminary sketch where I wanted several variables where the module would move inward and outward, up and down. So the module had some offset distances and orientation nodes. And I wanted to model that wellness inquiry using Maslow's hierarchy of wellness in developing the wellness center. All right, so I imagined that a client saw this and was like, I really like that. Can you go back and find the design that had something similar to this? And so I just happened to not delete a previous design that they'd seen before. and came up with something similar to the pyramid or the hierarchy of the theme. Each module experiences its ups and downs normal to the curtain wall. So the modules are dynamic, normal to the plane of the curtain wall, as well as dynamic in terms of oscillating open and closed. And so this is sort of what I scripted as a structure between the modules and the curtain wall, where there's a canvas sort of like above the modules of the structure, and the diamonds that are set in the frame, representing sort of that individual journey of self-discovery. And so this is a rendition of a curtain wall in the progress, like in the hierarchy of traversing the height of the building. And that's where I am so far. The end.
Did you have a chance, Ruby, to have the frame go away at some point? We had talked about in previous sessions, maybe the frame vanishes at some point.
Yes, that that does go away as the journey of the individual comes into self-actualization. The diamond gets bigger. You know, it starts out a little smaller, sort of embedded in a frame, but the frame or the environment or the weight of it sort of decreases as the person grows larger in their self-understanding and wellness.
Did the creation of the frame that you're showing us there sort of distract or take away from your ability to show that on the overall skin of the building?
No, the computer processing at the moment, see, there's a hierarchy of these frames. And so I'm very thankful to John that it's not due today because those different frames are processing differently. That's the one that's processed at the moment. But there is the one where I utilized the idea of the matrix sort of caving in on that person seeking that wellness. So this particular frame shows where the person is evolving, but there's a previous matrix that person is set in that actually sort of crushes in on the individual. So the frame is a little heavier at the bottom upon the entry of the building. But then that particular matrix sort of loosens up and the, diamond of the individual, it becomes more prominent as it scales the building.
One thing I'm wondering is, as that gold-colored matrix goes away, at some point your frame, which supports it, becomes a design element. And I'm wondering, when it's only the diamond in the frame, how you might utilize the supporting framework as actually something that is expressed.
One of the things I did have is to continue the canvas that's behind it, but that's something to think about more, because that matrix does go away towards the top, and around that point, I'm debating if the structure goes away and the diamonds fall into a pin connection as like earlier discussed in an earlier crit, or continue it up with, say, a background to it.
Yeah.
So the primary variable in play really is the height of the building and the way it's sort of extracting itself from the matrix, right? Are there any depth characteristics that happen or that change? Does the diamond get actually quite large by the time it's at the top of the building?
Yes, the diamond does get large. The matrix, they do have ups and downs normal to the curtain wall plane.
What I'm wondering is, in a certain sense, this this image right here, which is entirely gold, will actually become, say, silver and blue by the top. If you have
toward
yeah.
the top. Yeah.
Okay. So there's a lot more going to be going on this facade real soon when those things render up, right?
Yeah. Yes. This one, I don't know if I can. Let me see if I can do a dynamic zoom, if I can here. Zoom.
So I'm curious also on the behavior of like where it changes. Is it based off the program, or is it based off what are the variables that make it change?
The variables that are making it change are pretty much the hierarchy of self-discovery.
What dictates the hierarchy on the tower? Like where does like this psychological needs start, and where does the esteem begin? Like on the tower, which dictates which step you are in, or is the whole tower like a gradual gradation?
Well, the whole tower is a gradual gradation, but that's more to flesh out like the demarcation of height change or module change or growth change. So
I mean, for me, it's almost like there's way, I don't know, this is a 3-credit class?
Mm-hmm.
It's not a studio. There's a lot of metaphor here. There's a lot of like trying to manage the metaphor in different ways. Like in some ways, it's just a panelization exercise. You just like, if it's a gradual thing, it's like we're trying to map what you're doing in Grasshopper against a metaphor that's something that's imposed on this. Like you could just easily say, and you'll get no resistance from us tonight, saying like the tower goes from opaque to transparent. Okay, cool. How do you do that? What does it look like? How does it evolve? Like it does. Like there's no resistance in the metaphor for how these things work. And so I'm like, oh, it's a panelization problem. Okay, how do you turn the corner? How do you divide it? How do you decide how many panels to break it up into? What happens if you get to the edge and it's a half panel? Like what are some of those questions, and when is it most opaque? I guess I'm also curious too, like there's, with that panelization problem and the gradual change, is like trying to find moments like when there's step functions instead of just linear gradation, right? Which we're not used to in terms of parametric architecture, because every piece is unique. They gradually change across something. But like, is there a moment where it flips from one type of thing to another type of thing? And how do you start to program that? Like when we look in towers, there's like, okay, there's like in a Miesian tower, there's the mechanical floor in the middle, right? That's a topological difference from the glass panel to a different type of panel. How do we start to find those anomalies? And I know you're not doing it. I'm just like talking about it in relationship to the 3 projects that I've seen now. It's like, how do you find a moment where you have a different type of disruptive change within that, right? Or the way Eric was talking about it, when the gold drops away and the tubular frame is exposed. I don't think that you have any way embedded in what you've done with the scripting to make that happen. Do you?
Well, no, as elaborated, that's something I would like I'm still discovering, really.
I think
for me, that's like going back to the
debate-
Grasshopper script from the beginning, because if it's not there, it's not a change. It's not a change in the slider. It's a change in the fundamental makeup of what's driving what.
Yeah, and that was a lot of it is when you have that design concept. It's a two-way thing. It's yeah, this is a simple panelization, but there's also we have to understand that it's a design tool, and the design tool can assist us. So how do we start to? It's an exercise of how do we start to blend our design concept and design thinking into the scripting logic, and how do we accomplish that and make it successful? So that's one reason why there is this design narrative. So it sets up those rules for you, that rules of thinking before you actually get into the actual scripting. And so it should just be that next, okay, I'm thinking about this, and this is how, these are a few concepts of how I think the logic's going to be as this thing gradually changes, and then you can script it.
Question to Mystery and Carl. Have you ever seen anyone sort of diagram their script before they start scripting? And so this would be the meta diagram that we've been talking about. What's the thought about how you want the design to proceed? Meaning you can get locked into a linear-based script and not have provision for moments where the disruption happens. Have you seen meta diagrams like that?
Almost like a pseudocode kind of analogy,
exactly.
where you almost just like vomit out your thoughts on paper to make your own rules, and then sort of make or formalize it with the Grasshopper script. But with this, what's interesting is there is a substructure with another, like a two-layered, almost like a bone and muscle kind of analogy, which if, say, for instance, you would have a rule to say, okay, this is where the skeleton is, which is actually holding the frame, but as you start approaching or as you start progressing in height, it actually becomes like inside out. Then you're actually starting to set rules, and that's how you can start to translate it into almost like a script format, which then would do justice to the way you're sort of metaphorically or poetically talking about the diamond sort of fading out, or it starts to thin out as almost like the matrix of it, because then it becomes more explicit in terms of defining the rules, and then sort of, so that would then be your pseudo code, and then we actually go to Grasshopper and make it function in that sense. So there would always be almost like a backstory where you point out the dots, but then you're connecting it to almost think of it as different components which are simply connecting as an input or an output, sort of take it forward.
Realizing I'm gonna use all this in the fall. You realize I'm taking notes.
The person that I liked, right? There's different approaches to these things, and there's different, right? There's like a loop, there's a kind of slider, there's a Boolean set of operations, and so like at a very, very like different scale is Theo Jansen, who builds these like walking sculptures on the beaches in Holland. And the way that he talked about things, and they're almost like pneumatic tubes, and they have like release valves and this, and I think he calls one of them like a lyre, but they're
he does actually, because it actually reverses the flow of the information.
Right. And so they're like on-off Boolean switches as well that allows something to like, and when you stack up enough of those Boolean switches, like you don't know whether it's going to be positive or negative at the end.
Right. That's actually there's a video clip of that, and that would be a really useful thing to sort of have him. He presented at the Michigan Theater. Were you there for that?
No, I wasn't.
Several years ago.
Maybe I was.
He's terrific. He was Penny Stamps. He's
Yes.
terrific in person, right? But
I may have gone to dinner with him too, actually.
But I really like the idea of this kind of diagram, or this the pseudocode diagram, as a sort of a way to bridge Ruby between your narrative and the development, managing the narrative, and then getting into Grasshopper, so that one doesn't subvert the other or complicate the other. This would be actually important for Megan too. There's a design intention which gets subverted by coding it prematurely almost.
And often what happens is you'll go, and this happens to me all the time with CATIA, is like I'll embed all of these things and be explicit about them, and then realize like, oh, I need to like start over again because I didn't have those. And you like in CATIA, you can't make, like, things have rules. And so a circle can never become a square because, you know, of the way it's geometrically defined. A circle has a center point and a whole bunch of infinite points the same distance around it, right? But a square is not a rectangle, but a rectangle can be a square. And a spline could approximate a circle, but wouldn't be a circle. And so there are ways that you find ways to, like, I never model things with circles. I only model them with splines, because a spline can approximate a circle, but a spline can also be a blobby, nondescript type of geometry as well. And so there's ways that you can, like, cheat in some ways because you don't know ultimately where this thing is going to end up. And you try and build flexibility into the code at the front end so that you don't have to rebuild it later. All right, John, you want to keep us moving?
Yeah, keep us moving.
I was reading your face.
I was just thinking about the CATIA and how they did all that, making it flexible early. I was like, that's really interesting how that works out. But Michelle, do you want to go next?
Sure.
Ruby, you'll need to unshare, I think.
Yeah.
I'm clicking on the stop share.
Okay.
So, John, if you could.
Yeah, let me. I'm telling you to stop too. All right. Oh, it goes back to you. Stop participants from sharing.
My processing wheel is still turning.
It's strange, yeah. I can say.
I believe actually one trick, Ruby, would be for you to leave the meeting and come back, and that may automatically stop your sharing.
Okay.
Okay.
Not responding. Okay.
What about Control Alternate Delete?
Okay. Let me go to my manager. Yeah. Let me go to my task.
Hard reboot.
Another way to do it is for John to stop the meeting and we all come back.
Yeah, I can do that. All right, I'll end the meeting and then we just jump back on.
Rejoin. Yep.
Okay.